So in my presentation, I'm trying to boil it down to obstacles and solutions. So simplifying things a little bit and just showing you guys all the same problems we have. A little bit about myself. You already said that. Just want to point out that I'm coming from both sides. The research side, producing research data on the one hand, and implementing the technical stack, so to say. In the end, the website, the database that's behind it. So what are the obstacles that we all know? First, we've already talked about a lot of them, but let's just boil it down to three main obstacles that we all encounter. First, technical limitations, of course. There is the complexity of the data formats that nowadays get more complex, more and more complex, at least that's what we observe. And diverse formats, of course, complicate the process of data consolidation and then long-term preservation. And this leads to scalability because data becomes more complex, it becomes bigger, it becomes more and more. We need systems that are able to scale a lot these days because projects grow not just in data, but also in the whole environment sustaining these projects. So that's a big problem too, we all know. This one, we definitely, every single one of us here in the room knows about financial barriers. Of course, hosting costs, persistent storage costs a lot. So this is a very big obstacle. And then maintenance, we've talked about this. Ariana said a lot about that. And I feel like in Europe, we have less of an idea how to solve these problems than what Ariana said in Great Britain, because it's not there's no, like Jörg said, we don't really have an idea what happens after the project ends, because the idea here is the project is funded for, I don't know, 2, 3, 4 years, and then it's over. That's it. No one thinks about what's going to happen after that. At least the funders do not do so. But we do need ongoing funding, of course. Everyone knows that. We need stuff to manage the resources, and we need software updates, bug fixes, and so on. Which also then leads to talent and skill set. We need money to buy us talent and skill set, but that's not the only thing we need. And we need to find also talent and skill set, which, even if we had a lot of money, is in fact a very difficult thing to do. So because in our field, we need very specialized skills to manage and maintain these digital resources, in the digital humanities at least. So it's a very specialized niche, I would say, and you don't really find people, a lot of people who are capable of managing these systems and environments. So the buzz factor in our domain is very, very high. So it's mostly one person who has all the knowledge. And if this person gets run over by a bus, the project dies. And the knowledge is not passed on. And lastly, lack of institutional support. That is something that I think we also all know, but it is critical for long-term sustainability. Obstacles in real life. So just telling you about what happened with our system here in Graz in Austria. We have an institutional repository called GAMS, Geisteswissenschaftliches Asset Management System, so Humanities Asset Management System. It's a repository based on Fedora. And it has been around since 25 years now, and it's still alive. But our sysadmins keep telling us GAMS is going to die soon. At least once a week, they tell us, guys, you can't go on like this. If you push the system, put more and more data in it, play around with the triple store, have billions of triples in there, it's going to die soon. We can't do this anymore. But somehow they kept it alive. So our system admins are wizards, I guess. But they somehow managed to keep it alive. But that's a big obstacle, obviously. As I said, scalability. Very difficult, and it becomes more difficult every day. Maintenance. Actually, what is happening right now, we have a migration going on to the newest Fedora version. It's been going on for 5 years now. Why has it taken us so long? Bus factor. We had one mastermind who created GUMS 25 years ago, in the end of the 90s, early 2000s, and he retired. And it's been a very, very big problem. So the migration process is still not finished because it was very difficult to work with his code to migrate it to the new version. Which brings us to technical expertise. It took us 5 years to find someone to replace this mastermind I was talking about after his retirement. And it's actually a former student of mine now who does the job. He does quite a good job, as I think, but it's very difficult, as I said, to find these people who keep going. Another story of lack of institutional support. A former dean of the Humanities department here once literally declared war on our institute. He literally said the word war because computers are useless and the humanities only need books. So this is also a thing that happens when you're in a humanities department and working with an IT goal, so to say. Possible solutions, just my personal opinion, in the order of importance. To me, most importantly, there needs to be, in the first place, you need to have some kind of institutional repository. And institutional in a way that your institution supports you with the system. There's no other way. Otherwise, it won't be an institutional repository, but a private repository, or whatever you want to call it. But in my opinion, there needs to be some kind of institution that is able to financially support you and support you with all kinds of other needs that you have, so that it becomes a real institutional repository for long-term hosting. Secondly, I think also very important is cross-institutional collaboration. And I don't mean just institutional, same university, but worldwide, international collaborations. It's very important to have partners who can help you out with their expertise, who can help you out with their resources, maybe even help you out with their databases, with their very storage. I don't know, all kinds of things. So it's all about collaboration, I think. And then on the more technical side, in my opinion, everyone should expose their data as linked open data. Everyone should expose their data as RDF, because it makes things so much more easy. It makes data more accessible, it makes it easier to migrate, it makes it easier to understand for machines as well as for humans. For humans, maybe only if you have an ontology attached to it that explains the vocabulary that you were using and the constraints that you see to your data. And in my opinion, ontologies can also serve as documentation, machine readable and human readable as well. So those 4 things, in my opinion, would help a lot if you have it to have a sustainable environment. Other solutions that are possible as well, in my opinion, are cloud solutions at the moment, very expensive, but I think they should become less expensive very soon. And it would help a lot with scalability and robustness. How do we get money? Try to have a concerted effort in writing proposals everywhere you can. Together, the community effort, just try to write specifically for maintaining and archiving digital projects try to get funding for this. Yeah. It's more difficult these days, but it's the only way we can try to do it. Versioning, of course, that should come with your institutional repository, but it's not always the case, so you keep it in mind. To have something, you need to expose your metadata and the provenance of the data. Open source solutions, a no-brainer, you would say. But I think, at least I have the feeling that we're kind of going away from it again with all the emergence of systems like ChatGPT and other systems, other large language models. And it kind of feels, at least to me, as it would go towards the proprietary way again in the history, which is not a good thing, I would say. But of course, there are open source LLMs coming, and I really do hope so, that they are just as good as the things that we see now. But also a thing to keep in mind, try to have everything as open source solutions. And lastly, what we've seen in the latest present times, the emergence of large language models, and we've been using it extensively since they've been around for coding, writing, modeling, and it's actually very helpful to use those systems as assistants, and this could also help save costs, and then again have those budgets open for preserving the data. And I'm coming to an end to my presentation just with a few examples. So here, just stating why I think that linked open data and digital research have to go together. It's first the reusability. That's so easy when you expose your data as RDF, because it can be self-expressed. So the expressiveness of a data that's exposed with RDF is very big. You automatically get a database layer. You just put your RDF file into a triple store, and that's it. And your data should be automatically normalized, or you have to normalize it in order to make it linked data. And it's way easier to share your data, to link your data to other people's research data. I like to use this example because it's a very simple database from translators that had to flee the Nazi regime during the Second World War. And we just used two files, basically. One data RDF file and one ontology RDF file as OWL. And we had all the data in these two files. And this is self-explanatory within these two files. So all the metadata about the people, about their paths, where they went, the geographical data, it's all stored in these RDF files. And the front end, that's just a gimmick, as I'd like to say, that changes over time, and it's also something that will look differently over time. But what stays is the data behind it. And yes, definitely we have to talk about front-end preservation too. But for me, that goes a little bit too deep at the moment. At the moment, we should think about how to preserve the data itself. And in my opinion, linked open data is the only way at the moment to do so. Here, another good example from my colleague. Is a big project about historical accounts, where all of these historical accounts are preserved. All these table format historical data is also preserved as linked data as RDF. And in the end, just for all of you who have access now to the slides, you can see just an example of how to utilize ChatGPT 4 to very fastly transform a taxonomy from TI to SCOS and just do a task that used to take a long time for a student assistant or even ourselves, can be done within basically minutes now. And just to give you an idea that also we should think about these new ways saving time and money, and how we can use these new opportunities to keep our data preserved. Thank you very much.